Assalamualaikum warahmatullahi wabarakatuh. My name is Hani Sadira binti Muhammad Razalan. Today I want to do practice problem 4.3. Here are my solution. The question is, refrigerants 134 enter an adiabatic compressor. Unsaturated vapor at 100 kilopascal at rate of 0.7 meter cube per minute and exit at 1 megapascal pressure. If the isentropic efficiency of the compressor is 87%, determine the temperature of the refrigerant at the exits of compressor and the power input in kilowatt. Also show the process on a TS diagram with respect to saturation lines. First, figure out the data given. Data give the substance, which is refrigerant, (134A), and also give the system, which is compressor. The process of this experiment is adiabatic. From this question, they give P1, which is 100 kilopascal, and P2, which is 1.0 megapascal. As we know, we need to find the specific volume of 100 kilopascals, the enthalpy, and the entropy. We will get from table A12. Here are A12 table. As we know, 100 kilopascals for pressure, we need to find the specific value for 100 kilopascal, which is 0.19254 meter cube per kilogram. Next, we need to find the enthalpy at 100 kilopascal pressure. The enthalpy is 234.44 kilojoule per kilogram. Next, we need to find the enthalpy. The enthalpy is 0.95183 kilojoule per kg.K. So next, we need to find for the P2, P exits at 100 megapascal. So we use table A13. As we know, enthalpy 2S equal to enthalpy 1. So next, the enthalpy at phase 1, 0.95183. So 0.95183 in the middle of 0.9525 and 0.9179. So we need to do integration tables. For the enthalpy for the table, 0.9179 and 0.9525. View. From this side we put what H? What H for? H for what? Enthalpy. From this side you put enthalpy. For this side we put enthalpy. So for the enthalpy here, so next we put 0.95183. Okay, we need to calculate here. This is H2S. .9179 minus 0.95183. 0.9179 minus 0.9525. Next, go to 271.71 is 2S. 271.71 minus 282.74. H2S, and we will get the answer 282.53 kilojoule per kilogram. 282.53 kilojoule per kilogram. Okay, so next, the question given the rate of 0.7 to cube. So the rate of velocity 0.7 meter cube per minute divide with 1 minute per 60 seconds. So minute over minute cos we will get 0.01167 meter cube per second. Next, the isentropic efficiency. For the isentropic efficiency equal to 87% equal to 0.87. Next, we need to find the mass flow. Mass flow rate. So we need to find the mass flow rate. The equation for mass flow rate is mass flow rate equal to V dot over specific volume V. For V dot is equal to 0.01167, and the specific volume we will get for phase 1 is 0.19254. Equal, we will get 0.061 kilogram per seconds. Okay, so next we see the question. The question say we need to find the temperature of the refrigerant at the exit compressor. So we need to find the temperature exit first. We use the formula H2A equal to H1 plus H2S minus H1 over N. From the equation, we will get H1. H1 we will get from enthalpy 234.44 enthalpy 2S 282.53 and enthalpy 1 is 1 and the efficiency is 0.87. So next, so we will get 289.71 kilojoule per kilogram. So next, the question say you need to find the temperature. From this question, we need to see at table A13 the enthalpy for 2A in the middle of here and here. So we need to do the integration data to get the temperature. From the left side table, we put temperature and the right side enthalpy. Here we put 289.71 for enthalpy H2. Next, we put in the middle of 282.74 and 293.38. We get from here, from the enthalpy S2 in the middle of here and here. So as we know from here, we need to find the temperature. The temperature is 60 in the middle, 60 and 70. 60, 70. So we need to find temperature 2. So after we calculate, we will get T2 equal to 56.5 degrees Celsius for temperature exit. So next, from the question for B power input, so we need to find the power input. For B power input, as we know, power equal to work equal to mass flow rate times enthalpy 2A minus enthalpy 1. So as we know, we get the mass flow rate from here 0.061. Then H2A from here, H2A, which is 289.71. 289.71 is enthalpy 1, 234.44. 234.44. We calculate, we will get 3.37 kilonewton. Also show the process on a TS diagram. So we draw the TS diagram here. TS. So first we need to label one 0.0 megapascal here and 100 kilopascal. So 2, which is T1 T2 equal to 56.50 and 1, which is T1 equal to negative 6.27. Here are the this one actual process. Isentropic process. Okay, that's all for me. Thank you.